All right, you're tuning in because you want to get smart, fast on something truly colossal. And nothing quite screams colossal like Argentinosaurus.
Yes, for sure.
We're talking about a real contender for the largest land animal ever. So forget those long documentaries. This deep dive is, well, your express ticket to understanding this prehistoric titan.
Precisely. We've basically sifted through the dense scientific literature,
Mm,
the original paleontological papers, all the follow-up analyses to bring you the core knowledge about Argentinosaurus.
right.
Our aim is really to explore its fascinating discovery, grapple with its mind-boggling size, try to understand its place in the dinosaur family tree, and picture the world it lived in, all without getting too bogged down in jargon.
Okay, let's do it. So let's rewind to the beginning. It's kind of a classic story, right? A farmer finds something amazing.
Yeah, pretty much. 1987, a farmer named Guillermo Heredia on his farm Las Overas near Plaza Huncul in Argentina.
And he finds this bone.
He finds this huge thing. Yeah, it's
Yeah.
massive. He actually thought it was petrified wood.
Petrified wood. Can you imagine?
I know. Turns out that petrified log is now thought to have been a fibula. The outer bone in your lower leg.
Wow. It's amazing how these things start, isn't it? A chance discovery?
It really is.
Yeah.
Someone completely outside of paleontology kicks off this huge scientific thing. So that bone, it found its way to the Museo Carmen Funes.
Okay.
Then, in early 1989, the paleontologist Jose F. Bonaparte, a big name, he took the lead on a much larger excavation at the site.
So that's when things got serious, scientifically speaking.
Exactly. That's the real start of the investigation into what this thing was.
And that bigger dig, that's what unearthed the key evidence, the holotype specimen.
That's right, MCF PVPH1.
Yeah.
That included 7 dorsal vertebrae, the backbones, plus the underside of the sacrum.
Which is the part fused to the pelvis.
Correct. Specifically, the 1st to 5th sacral vertebrae and some ribs attached to them, and also part of a dorsal rib. So, not a complete skeleton by any means, but some really significant pieces.
And getting them out wasn't easy, I gather?
Oh, definitely not. They were embedded in incredibly hard rock. They actually needed pneumatic hammers to chip them out.
Pneumatic hammers. That tells you something.
It really does. It speaks to the challenges. It's not just finding the bones, it's the painstaking work of getting them out safely.
So fast forward a bit, 1993, Bonaparte and Rodolfo Coria, they officially describe and name it.
Yep. Argentinosaurus swingulensis. Argentinosaurus lizard from Argentina. Pretty straightforward.
Makes sense.
And Huinculensis refers to Plaza Huincul, near where it was found.
A nice, clear connection to its origins.
Mm-hmm. But the interpretation of that very first bone, the petrified wood, it evolved.
How so?
Well, Bonaparte and Coria initially thought it was a tibia, the shin bone.
Okay.
But then later research in 2004 by Gerardo Mazzetta and colleagues, they looked closer and concluded it was actually a left fibula.
So the calf bone instead. It shows how science refines things, right? Even the basic identification.
Absolutely. It's a constant process. And the story of what we found keeps kind of unfolding. There are these other bones from the same place.
Like what?
Well, a complete femur of the thigh bone. It's in the Museo Carmen Funes now, though it's a bit, flattened by time and pressure.
Right.
Plus, there's a fragment, just the shaft, of another femur at the La Plata Museum.
Are they definitely Argentinosaurs?
Well, that's the thing. There's still some uncertainty. Even as recently as 2019, scientists were debating whether these femora really belong to Argentinosaurus.
Huh. It's like piecing together a puzzle with maybe some extra pieces that don't quite fit.
Exactly. This uncertainty around referred specimens, it really highlights a fundamental challenge in paleontology. We're often working with an incomplete picture.
And that becomes even more critical when you try to figure out the size, right? The sheer scale of this thing.
Absolutely. Estimating size and mass, it requires careful comparisons with related sauropods that are more complete. And using various scaling techniques, it's not straightforward.
So let's talk length estimates. When people first started trying to figure that out, what were they thinking?
Well, Gregory Paul, back in '94, he suggested something like 30 to 35 meters.
Okay, huge.
Yeah. Around the same time, Bonaparte and Coria also landed on about 30 meters. Then Kenneth Carpenter, in 2006, he used Saltosaurus as a comparison and also got around 30 meters.
Interesting how those early estimates were kind of similar.
Yeah, it suggests some early consensus based on what they had then. But as more data came in and different sauropods were used for comparison, the numbers started to shift a bit.
Right, like who?
Well, in 2008, Jorge Calvo and his team looked at Futuloncosaurus and suggested maybe a bit shorter, under 33 meters.
Okay. But then there was a really big estimate, wasn't there, from Sellers and colleagues in 2013.
Ah, yes. That was based on measurements from the actual mounted skeleton in the Museo Carmen Funes. They came up with nearly 40 meters, 39.7 to be exact.
Whoa, based on the museum mount.
Yeah, a very direct approach. But not everyone agreed. Scott Hartman, same year, argued it was probably a bit smaller, maybe closer to Portosaurus around 27 meters.
Why the difference?
His reasoning was partly based on seeing Argentinosaurus as a more basal, sort of earlier titanosaur then,
Mm-hmm.
which might imply different body proportions, maybe shorter tail, narrower chest.
So how it fits in the family tree affects the size estimate.
It can, yeah. And Gregory Paul revisited his estimates too. He went back to 30 meters in 2016, but then up to 35 meters or even longer in 2019.
What changed his mind?
Likely influenced by newer discoveries, a better understanding of other big South American titanosaurs.
Yeah.
It helps reconstruct the missing bits, like the neck and tail. It's always being refined.
And what about the weight? The mass estimates must have a similar story.
Oh, definitely. Paul's first guess in 94 was massive, 80 to 100 tons.
100 tons.
Yeah. Then Mazzetta's team in '04 gave a range of 60 to 88 tons, settling on maybe 73 tons is most likely.
Okay, still enormous.
And that Seller study in 2013, the one with the big length estimate, they used their digital model and got about 83.2 tons. So, generally in that ballpark using different methods.
But I remember seeing even higher numbers mentioned, like 90 tons.
Yeah, Benson and colleagues suggested 90, even 95 tons in
Yeah.
2014 and 2018. But those higher figures had been questioned a bit, maybe a larger error range in the calculations.
Mm-hmm.
Then in 2016, Gonzalez-Riga's team used that isolated femur, the one we're not totally sure belongs to Argentinosaurus.
Right, the uncertain one.
And they got a huge 96.4 tons.
Yeah.
Impressive, but it comes with that asterisk,
Definitely. So where do the more recent estimates land?
Well, Paul brought his numbers down a bit from his initial guess. Over 50 tons in 2016, then refined to maybe 65 to 75 tons in 2019, based on his newer reconstructions.
Okay.
Campione and Evans in 2020 were also around 75 tons.
Yeah.
And just recently, 2023, Paul and Lara Mendy suggested the holotype specimen itself points to 75, 80 tons. They even mentioned Bruvacchiasaurus might be bigger, but that's based on really scrappy remains.
Mm-hmm. So, bottom line, it was immense. Doesn't matter the exact number, it was huge.
Absolutely. And naturally, you want to compare it to the other giants. Names like Portosaurus, Foodonkosaurus, Dreadnoughtus, Paralidoton,
Mm-hmm.
even Antarctosaurus giganteus and Alamosaurus get thrown around.
But the studies don't always agree on who was biggest, do they?
No, they don't. Sometimes they're put in the same size class, other times not. Like Carbolito and colleagues in 2017, they actually argued Patagonatan was bigger than Argentinosaurus based on their analysis.
Oh, really?
Yeah, but then Paul countered in 2019 saying Argentinosaurus had a longer back, a longer dorsal vertebral column. So it really shows how interpretations change as we learn more.
It's a moving target.
It is. And then you've got these tantalizing hints of maybe even bigger things like Marapunosaurus or that giant Mamenchisaurid.
Mm.
But they're known from so little. Just fragments, really.
Intriguing possibilities, but hard to say for sure.
Exactly. And it's worth remembering, some Diprotodontids like Supersaurus might have been longer.
But not as heavy.
Probably not as massive, no. Argentinosaurus was likely much bulkier. But, of course, the undisputed heavyweight champion is still the blue whale.
Right. Over 150 tons. Puts everything in perspective.
Definitely. So let's look at the actual bones we do have, the vertebrae, for instance.
Okay, the backbones, what do we know?
Well, it likely had about 10 dorsal vertebrae,
Mhm.
and they were just gigantic. One reconstructed vertebra,
Mm-hmm.
1.59 meters high, 1.29 meters wide,
That's taller than me.
easily. Yeah. And the main body, the centrum, up to 57 centimeters wide. Gregory Paul figured the whole dorsal column was nearly 4.5 meters long.
Wow, just the back section.
Yeah, big chunk of its length. And the structure is fascinating, too. You mentioned they were
They're
episticalis.
concave at the back, right?
Exactly, like a ball and socket joint. Probably allowed some flexibility, but kept things strong.
Mm-hmm.
And the pluricals, those holes on the side.
They're sacks.
Yeah, air-filled cavities. They were actually proportionally small in Argentinosaurus and located more towards the front of the centrum.
And inside the bone itself, you mentioned camelot structure.
Right, think honeycomb or sponge. Lots of tiny interconnected air-filled chambers inside the bone.
To save weight.
Precisely. Reduces the weight dramatically without sacrificing strength. It's brilliant natural engineering, like bird bones, but on a colossal scale. We also see big cavities, maybe 4 to 6 centimeters across,
Mm-hmm.
in the dorsal and sacral vertebrae. more weight saving.
What about the ribs attached to those vertebrae? Anything unusual there?
They were described as tubular, cylindrical,
Oh.
and there was some debate about whether they were actually hollow.
Hollow ribs?
The first description in '93 suggested they might be another weight saver. But later researchers thought maybe that hollowness was just erosion or damage after death. So it's still a bit debated.
Okay. Moving down the spine to the hips, the sacrum. Probably 6 vertebrae fused together there.
Probably 6, yeah, though the last one wasn't preserved. What's interesting is the centra, the main bodies of the second to fifth ones, get smaller as you go downwards.
Huh. Why would that be?
Not entirely sure, but it relates to how weight was transferred. Also, the second sacral rib that was found is noticeably bigger than the others. All clues about how the pelvis handled that immense weight.
Now, you mentioned earlier, because we don't have the whole backbone, there are different ideas about where the vertebrae we do have actually fit.
Exactly. It's a puzzle.
Mm.
Based on subtle shape differences, different scientists have proposed slightly different orders for those dorsal vertebrae.
Like one bone could be the first or the third or the fifth.
Pretty much, depending on the study. Another one might be the second or way back at the 11th position. It really highlights the challenge of reconstructing from incomplete bits. Different analyses lead to different conclusions.
And then there's this whole thing about the hyposphene hypantrum articulations. Sounds complicated.
They're basically extra joints between the vertebrae that some sauropods have. They help lock the spine together.
For extra support.
Yeah, for rigidity.
Right.
But whether Argentinosaurus had them and what they look like is debated. The preservation isn't perfect.
So what did the original describers think?
Bonaparte and Coria thought they were present and actually enlarged, maybe with extra bits extending downwards. They figured this added extra stiffness, which makes sense for such a huge animal.
But others disagreed.
Yeah, later researchers pointed out many titanosaurs lack these well-developed joints. They suggested maybe Bonaparte and Coria just saw thickened, bony ridges laminae on the vertebrae.
Okay.
Then in 2005, Sebastian of Pestagia suggested maybe it was a bit of both. He called them hyposphenal bars, thickened laminae, that basically did the same job of reinforcing the spine, even if they weren't true hyposphene hypantrum joints.
So still providing stiffness, just maybe not the standard joint.
Exactly. It's a great example of how science re-examines evidence and interpretations evolve.
Let's shift to the limbs. We mentioned that femur, the thigh bone that was found separately. How big was that again?
That complete one is massive, 2.5 meters long.
2.5 meters.
And the shaft circumference, about 1.18 meters around. It's estimated the original length might have been slightly more, maybe 2.56 to 2.58 meters.
And that's bigger than other giant titanosaur femurs.
It is. Bigger than the known complete ones from Antarctosaurus giganteus and Patagotitan majorum. Really underlines the potential size.
And the holotype itself, it didn't have a femur, but it had that fibula.
Right.
The one mistaken for a tibia initially.
Right. That fibula is 1.55 meters long, relatively slender. The misidentification led to comments about a short canemial crest, which is a feature of the tibia.
But once they realized it was a fibula,
it made more sense. It lacked the typical tibia features and looked much more like other sauropod fibulae. An important correction for understanding the limbs.
Okay, so let's try to put Argentinosaurus in its place. Classification. Where does it fit on the big dinosaur family tree?
Well, Titanosaur classification is complex and still evolving. For a long time, pretty much all Cretaceous sauropods just got lumped into Titanosauridae.
Kind of a catch-all.
A bit, yeah. But when Bonaparte and Coria described Argentinosaurus in '93, they felt those hyposphene hypantrum things set it apart from the typical titanosaurs.
So what did they propose?
They saw similarities with Andosaurus and Apactosaurus, which also seemed to have these joints. So they created a new family, Andosauridae, for those three.
Okay, so 2 families within the bigger group, Titanosauria.
That was their idea, yeah. Recognizing shared ancestry, but highlighting those differences.
But that division didn't quite hold up over time.
Not entirely. Research in '97 by Salgado and others actually put Argentinosaurus within Titanosauridae, closely related to Opisthocoelicodea.
Oh, okay, so back into the main group.
That view got more support in 2002 as well, but then the validity of those families themselves started getting questioned.
How so?
Well, Wilson and Upchurch argued in 2003 that Titanosauridae was based on Titanosaurus, which is kind of poorly defined itself. And Andosauridae, they argued, was based on primitive features, not unique shared ones that define a real evolutionary group.
So maybe neither family was a natural grouping.
That was their argument. And later studies found Andosauridae was likely paraphyletic, meaning it didn't include all descendants of a common ancestor.
Okay, so if those families are shaky, how do we classify these things now? Lithostrutia, is that the key group?
That's a major one, yeah. Defined by Upchurch and colleagues in 2004 for the more advanced or derived titanosaurs. And importantly, their analysis placed Argentinosaurus outside Lithostrutia.
Meaning it was more basal, earlier branching.
Exactly, a more primitive member of the overall titanosaur lineage. And most studies since then have generally agreed with that placement.
Interesting. So it's important for understanding how the later, more derived titanosaurs evolved. What about Lonkosauria? That's another group with some giants, right?
Yes, named in 2007 by Calvo's team, initially including Futalonkosauros and Mendozasaurus, where Argentinosaurus fits relative to the Lonkosaurus. That's been debated.
How so?
Well, Carbolito's 2017 study actually found it was closest to Patagotitan and outside Lonkosauria.
But other studies put it inside Lonkosauria.
Exactly. Gonzalez-Riga's work in 2018 and 2019 argued strongly for placing Argentinosaurus within Lonkosauria. They even proposed Lonkosauria was part of a bigger group called Colossosauria, nested within Lithostrutia.
Colossosauria, aptly named.
Definitely. It suggests a potentially close relationship between these absolute giants.
It just shows how dynamic this field is. New analyses keep tweaking the family tree.
Absolutely. And there's still other views. A 2018 study suggested Argentinosaurus might not be a Lonkosaurian. Maybe it's more basal or close to Eupacthosaurus.
Wow.
And another 2019 study put it in Lonkosauria, but then suggested Lonkosauria itself might be outside Titanosauria altogether.
Yeah.
So, yeah, its precise position is still very much an active area of research.
Okay, let's switch gears. Paleobiology. How did this thing actually live? What allowed sauropods like this to get so incredibly huge?
It's likely a combination of things. Efficient feeding, for one.
Yeah.
That long neck lets them browse a huge area without moving their massive body much.
And no chewing, right?
Yeah.
Sculpting it down.
Right, saves energy. Fast growth rates were probably key, too. Plus, laying lots of relatively small eggs, high reproductive output.
Safety in numbers, maybe.
Possibly for the species, yeah.
Yeah.
And internally, a really long digestive tract to get every bit of energy out of tough plants. And of course, sheer size is great protection against predators.
Speaking of reproduction, what do we know about Argentinosaurus eggs?
We haven't found Argentinosaurus eggs specifically, but titanosaur eggs in general are known. Probably around a liter in volume.
A liter. That sounds big, but tiny compared to the adult.
Exactly. Hatchlings would have been less than a meter long, under 5 kilos. Imagine that growth spurt.
Incredible. How long did they live? Any ideas?
Based on bone growth rings and other sauropods, Hallett and Wadle estimated maybe reaching sexual maturity around 8–10 years old.
Okay.
Physical maturity around 20, and maybe living to about 30 years old.
Figure
Just
out.
estimates, of course.
Still gives you a ballpark. And predators. You mentioned size was a defense, but surely something tried.
Oh, absolutely. The evolution of giant sauropods probably drove the evolution of giant predators, like an arms race.
Makes sense.
And Argentinosaurus lived alongside Maposaurus, a huge carcharodontosaurid theropod.
The shark-toothed lizards.
Yep. And Maposaurus fossils have been found in groups, which suggests
Pack hunting. To take down something as big as Argentinosaurus?
it's the theory. It paints a pretty dramatic picture of life back then.
It really does. Now, one really cool area is figuring out how something this big even moved. That computer modeling study from 2013.
Yes, Sellers and colleagues. Groundbreaking stuff. They built a detailed digital model of the museum skeleton, estimated the mass at 83 tons,
Right.
and then used simulations incorporating muscle physics from living animals to basically teach the digital skeleton how to walk.
That sounds incredibly complex. What did it learn? What kind of walk did it do?
The simulation suggested a pace gait was most likely. That means the front and back legs on the same side move together.
Okay, like a camel or giraffe sometimes does. And how fast?
They estimated a top walking speed around 7.2 kilometers per hour, about 5 miles per hour.
So not chasing anyone down, but decent for its size.
Decent, yeah. But their big conclusion was pretty profound. They suggested Argentinosaurus, with its shape and mass, might have been right at the functional size limit for land animals.
Pushing the boundaries of physics, basically.
Kind of. They theorized anything significantly bigger might have faced serious biomechanical problems like joints failing. Of course, they admitted it was a simplified model.
And has that speed estimate held up?
It was revised slightly downwards more recently, actually. A 2025 study suggested maybe closer to 5.7 kilometers per hour, so about 3.5 mile per hour. But the idea about it being near the limit still holds weight.
Fascinating. Okay, let's set the scene. The paleo environment. Where exactly in Argentina was it found?
Neuquén province in Patagonia, The specific rocks are called the Huinkel Formation.
The Pwinkle Formation, what was that like back then?
Well, the sediments are mostly yellowish and greenish sandstone, some with volcanic ash mixed in.
Volcanic activity nearby then?
Seems likely. And these sediments were laid down by a braided river system. Lots of shifting channels and sandbars.
And when was this?
Upper Cretaceous. Middle Cenomanian to early Turonian, roughly 96 to 92 million years ago, though some studies push that range a bit later.
So, a river landscape, volcanoes, what about plants? What was there to eat?
Fossil pollen tells us quite a bit. There were things like hornworts, liverworts, ferns, club moss relatives.
Basic stuff.
Yeah, but also gymnosperms like cnidophytes and conifers.
Yeah.
And significantly angiosperms, the flowering plants, were around too. So a pretty diverse menu for a giant herbivore.
Sounds like enough to feed a beast like Argentinosaurus. And it wasn't alone, right? The Huinkel Formation is known for lots of fossils.
Incredibly rich, lots of vertebrates, fish like lungfish and gar, turtles, lizards, snakes, relatives of tuataras, crocodiles.
The whole ecosystem.
Absolutely, and dinosaurs galore, especially in the older layers.
Besides Maposaurus the predator, what other dinosaurs were neighbors? Sounds crowded.
It really was. There was another titanosaur, Chokansaurus. Different types of sauropods, too, the Ravacusaurids like Cathartosaura and Limosaurus.
More long necks?
Yep, and more predators besides Maposaurus.
All right.
Several abelosaurids, those short-armed guys like Scorpiovenator, Ilocalesia, even Carnotaurus and Abelosaurus.
Wow, quite the rogues gallery.
And others, too. Anoraptor, Gualicho, the long-clawed Austroraptor, plus various iguanodonts, the plant-eaters. It was a seriously dynamic place.
What an incredible world. So, wrapping this deep dive up, what are the absolute key things to take away about Argentinosaurus?
I'd say it was a true giant from late Cretaceous Argentina, known from incomplete but really significant bones that show immense size. Its exact classification is still debated, which tells us a lot about titanosaur evolution, and it lived in this incredibly rich, diverse ecosystem with some truly fearsome predators.
Yeah, and for me, what really stands out is that ongoing debate about its exact size compared to the other giants. It shows science is always refining things, and those locomotion studies, trying to figure out how it walked, just amazing, pushes our understanding.
Which brings us to a final thought for you listening. Just consider how discovering creatures like Argentinosaurus really stretches our whole concept of what's possible for life on land. What other unbelievable secrets are still buried out there, waiting to change how we see the past. It definitely makes you want to explore more about titanosaurs and the Cretaceous world.